Hey guys, it's me, Miss Eason, and I am here today to talk to you guys about line graphs and a little bit about bar graphs. So let's get started. First of all, if you have already printed out the notes, awesome. If not, go ahead and have a piece of paper out and ready so that you can learn along with us. So here we go. Line graphs, I will let you guys read through this slide, but what I do want you to remember is that line graphs are often used to show how things change over time. So a lot of times when we look at line graphs, the x-axis is going to show time, and we're going to look at how things are changing. So let's get started. So a line graph is shown below. Use the graph to fill out the chart. So this chart's already been filled out, but let's talk about how you would do this. So for day 1, so this is the days, that goes along our x-axis, and the number of shoppers is along our y-axis. So what you're really just doing is looking for your x and y coordinates for each of these points. So for day 1, if I go over to 1 and go up to where the line is, it is at 300. Let me make my little marker a little bit bigger. Okay, it's at 300. So day 1 is 300 shoppers. Day 2, if I go over on the x-axis to 2 and go up to where my line is, we can see it's around 275. So we're looking for these points. Day 3 would be my x-coordinate, y is going to be 175. So you can see it's how far did I run, how high did I jump. Day 4, we go over to 4 and we go up to 200. And day 5, we go over to 5 and up to 100. So that's how you would fill out this chart that's here. The next question down here at the bottom is the graph increasing or decreasing? So when we look at data like this, we are not looking at each individual point, because you can see that on some of these, we are decreasing. So our line is going down, kind of like going down a slide. Here it's really going down, so it's decreasing there. But at this point, it's actually going up a little bit. It's increasing. And then down here, it's going down the slide again, so we're decreasing. So yes, we have increases and decreases, and that's what you'll normally see on a line graph, but we're looking at the overall, sorry, I'm distracted. We're looking at the overall trends on the graph. So overall, 3 out of 4 of these are decreasing. So we would say that this graph is decreasing its data. We can also kind of look that it started up here at 300 and now we're all the way down to 100 at the end. So we definitely see a decrease in the information. The next problem we have here says we're going to put this data into a graph. So again, you can already see it on my screen, but if you have your notes, let's go ahead and fill this out. The days are across the bottom. Remember, change over time. We usually put time across the bottom of our line graph. And then the y-axis for this one is height in inches. So on day 1, the height is 2 inches. So I'm going to go over to day 1 and go up to 2, and that's, oops, I had a tiny little dot there, hang on. And that's where that first dot will go. So you will plot your points first, put the dots down, and then you can connect them. Day 2, we go over to day 2 and go up to 2.5, and that's our next point. Day 3 says the height was 3 inches, so we go over to 3 and up 3. Day 4, the height was 5, so we go over to 4 and up to 5. Day 5 is 5, and day 6 is 6. So you can see where I kind of laid these dots down, and then you just connect them to create your line graph. So looking at the trends on this data, is this mostly increasing or decreasing? And this one's pretty easy to see. There is a day when there's no growth, but for the most part, this is definitely increasing data. So we start at 2, we're ending up here at 6, and we see this trend of growth and moving up as we go through our graph. On the next slide, we have some questions to go along with this guy. So I'm going to kind of flip back and forth here. But what day did the plant not grow? And I want you guys to look at this carefully. So we can see that between day 4 and day 5, that our graph, and let me make sure I don't have a giant pen here, our graph goes straight across, okay? Straight across, no growth, nothing is moving. All right, so the question is to answer, is this day 4 data or is this day 5 data? Okay, and we would actually call this day 5 data because it started at day 4 at 5 and then we moved to day 5. So the answer to number 1, what day did the plant not grow, would be day 5. Because this from 4 to 5 is when we see this flat line. So we're moving towards 5. I hope that kind of makes sense. What is the plant's maximum height? So maximum is when was it the tallest? And if we look at our graph, the tallest this plant was 6 inches, way up here at the top. Good job. Next, what is the range of the height of the plant? So when we talked statistics and we talked about range, we talked about taking our biggest piece of data and then subtracting the smallest piece of data. So if we think about this plant, the tallest this plant was, the maximum was 6 inches. So that would be our biggest data point. The smallest data point was down here when we started at 2 inches. So to find the range, we are going to subtract 6 take away 2, and we get 4 inches. Last one for this graph, which day had the most growth? So take a second and I want you to look at this and I want you to think about what we talked about with this one when there was no growth on what your answer would be. So we're looking for when was there the most growth. Okay, couple different strategies here. Hopefully you've figured it out. Couple different strategies though. When we are looking at a line graph and we are looking for the most growth or the biggest increase in something, we're looking for the line that has the highest slope. And so this line right here, you can see is really steep. Like if I was going on my bicycle and I had to go up this hill, Miss Eason anyways would have a lot of trouble doing that. So you're looking for what's the highest slope. So this is where we see the biggest increase. Now you could also go through and subtract 6 take away 5. So I know this was 1 inch of growth. This was 0 inches of growth. From 3 to 5, the difference between those two is 2 inches of growth. So you can go through and do the math to figure this out. But really it's kind of easier when we have it on a line graph to look at this slope and look for which one has the steepest slope. So, is it day 3 or day 4? Okay, because this is our data set we're looking at and it is pointing or it's moving towards day 4, then we're going to say day 4 had the highest growth. Yay, let's move on. All right, a new line graph here. This one says the manager at a sports store kept track of the number of four-wheelers sold over a 5-month period. I don't know about you guys, but I love four-wheel riding, so that's exciting. Little tidbit about Miss Eason. Use the chart to put data on the graph. So again, we've already done this one for you, but let's go ahead and talk through it just to make sure that you know exactly how to do this when you have to do it on your own. Let me again get my bigger pen here. Okay, so month number 1, there were 24 four-wheelers sold. So I'm going to go over to 1 because you can see months is across the bottom. Again, your x-axis a lot of the time is going to be time going by. How do things change over time? So time is at the bottom for months. So I'm going to go to number 1, and in month number 1, we sold 24 four-wheelers. So we're going to go to up to 24. and this is where our line graph is going to start. Month number 2, there were 16 four-wheelers sold. So I'm going to go over to month 2, and I'm going to go up to 16, and that's my next point on this line graph, my next marker. Month 3, there were 27 sold. So that's way up here. Month 4, we go over to 4, and there were 22 sold. So I'm going to go up to 22 and make that point. And hopefully you guys are seeing the relationship between these line graphs and coordinate grids, that we're going over across the x-axis and then going up to find our data point. The last one is month 5. We go over to 5, and they sold 19, so it is here. So you can see I put my points in, and once you put your points in, you can go ahead and connect those dots to make your line graph. All right, let's look at the questions that go along with this guy. What month had the most sales? The most, the top, which month? I mean, you guys have been answering questions like this with graphs for a long time. So the month that had the most, it's the highest point on our graph, and that is month number 3. What month were the sales low? All right, so looking at our line graph, where is, oops, I'm making dots everywhere. Which month did we have the lowest amount sold? So we're looking for the lowest point on our line graph. So that would be month number 2, you got it. And last but not least, how many total four-wheelers were sold? So when we go back, for total numbers sold, and you can use the graph to answer this, but I certainly think we have this beautiful table over here on the side that's going to make it a lot easier, because what you're going to do is actually add up all of these different numbers, because we know that 24 were sold this month, 16 more were sold, 27 more were sold, so you're going to add up these numbers. Once you've added those numbers, you get 108 four-wheelers. All right, so that is what we have to share with you guys about line graphs. Let's talk really briefly about bar graphs. You guys have been doing bar graphs since you were itty bitty, so we're not going to spend too much time on it, but you know, we'll go back over it and make sure that you are thinking about them and remembering them as we talk about statistics. All right, so bar graphs are used when we are comparing categories of data. So that's kind of their use, and you can read through that on your own. Let's go ahead and get started. All right, filling out the table using the chart below. And again, I already have my numbers filled out here, but let's just talk through it and make sure you guys see exactly where we're getting this information. So we have days and numbers of bus riders. So days are across the bottom, and just like line graphs, sometimes we have time across the bottom, but bar graphs are a little different. We don't always have time across the bottom. So just keep that in mind. On Monday, we see that this bar goes all the way up and touches that line that says 24, which means there were 24 bus riders on Monday. On Tuesday, this bar goes all the way up and touches that line that says 18. So on Tuesday, there were 18 bus riders. You guys have got this, right? I thought so. All right, I'll keep moving. You guys have got that. If you don't, email me and we'll talk through it together. So the next one says a visual representation to show popularity of category, or how many chose a specific category selection. That was a mouthful. Okay, it is good for making comparisons. So this is just telling us why we would use a bar graph like this. Now you can see across the bottom of this bar graph, there is not it's not showing time, so we're comparing the towns and the number of towns. So it's just talking about names and how often those things occur. Just another little fact of information, if you're creating these graphs in Excel or online, this first graph we looked at would actually be called a column graph because it's going straight up in the air, and this one would be called a bar graph We call them both bar graphs in math, but if you were wanting to create them, the difference between those two is if it's sideways, it's a bar graph. And if it's up and down, it's a column graph. So there's your digital lesson for the day. Anyways, I'm out of control. Let's keep going. Let's look at the questions. So which name is used for 50 towns? So if we go here, we have to look for the number of towns. We want to find which one has 50. So we go across to 50 and we go up and we find the bar that kind of lines up with that 50 and we see that it is Finland. Next, which town name is most likely to be used? So if it's most likely, it's going to have the most data points. So for this one, the town name that has the most is Faxland. Weird. I would think that would be the least out of these, but you know, I don't know anything about naming towns. So Faxland definitely has the bar that goes the farthest, so we would assume that it is the most likely to be used. What is the least common town name? Least common. What is the smallest data set that we're looking at? And we can see here that Riverland only goes maybe 25, maybe a little bit less than 25. So Riverland is definitely the least common of these town names. So that will be Riverland. And last, which two names on the graph are used for the same number of towns? Same number. We're looking for two towns that have the same size bar. So Oakland and Heartland both go to 40. So those are the two that have the same number. Cool. Last one here. Fill out the chart using the table below. Okay, again, I've already got mine filled out, but let's go ahead and fill it out together and talk through it just so we can make sure that you are clear on this. So days and number of car riders. So the days are listed here on the graph across the x-axis, Monday, Tuesday, Wednesday, Thursday, Friday, and we have those listed in this first column on the table. Number of car riders. So if we go to Monday and we follow that bar or that column straight up, it stops at the line that goes next to 9. So on Monday, there were 9 car riders. Tuesday, that column goes straight up to 21. Wednesday, that column goes all the way up and touches the line for 25. Thursday, that column goes up and touches the line for 12. And Friday, it goes up and touches the line for 6. So that's how we get that data in our table. Let's look at the questions. How many car riders were on Monday? Monday, if we go to our column for Monday, we can go up and find that data right here that it's at 9, or you can use your table since you already did this and find Monday and go across and find 9. But there were 9 car riders on Monday. How many car riders on Tuesday? Same process. We can go over to Tuesday, go all the way up to the top of that column and see what line it touches, and it touches line 21. Did the number of car riders increase or decrease between Monday and Tuesday? So between these two numbers, what happened? And if you think about this, kind of like our line graph. So on Monday, our dot would be here at 9. And on Tuesday, our dot would have been up here at 21. And let's look at that line. Is that line increasing and going up, or is it decreasing and going down? Well, that line is definitely increasing. So we're going to say that between Monday and Tuesday, our data is increasing. Were there more car riders on Wednesday or Thursday? Well, Wednesday, we were all the way up here at 25 car riders. And Thursday, we were down here at 12 car riders. So which day had more? Which one is bigger? Which column is taller? Which number is greater? Wednesday. And last but not least, which day had the fewest number of car riders? So if we look at this graph, we're looking for fewest, so which column is the shortest? And that would be Friday. So I hope that this was informative for you guys. If you have questions or you need help while you're working on your assignment, please let me know. You can email me or write a comment in Google Classroom, and as soon as I see it, I will try to get back to you. But until then, I miss you, stay safe, and I will talk to you later. Love ya, but I gots to go. Bye.